All right, welcome to video 3, probably the longest one. Maybe not though, but probably. So we're gonna start video 3 by talking about what we just talked about. And again, you hopefully have done the homework problems after video 2, so this is hopefully not as soon after video 2 for you as it is for me. But we found these 3 inverse functions. Let's look at what this looks like, okay? We're gonna go to desmos.com, again, a great resource. www.desmos.com. You can see it right here. And then let's graph some things. I graph x plus 5 and its inverse function, if I can get there, is equal to x minus 5. There is symmetry here. Okay? And specifically, I'm going to graph a third function here. A function, its inverse, and the third thing. Make it a dashed line. Whenever we have inverse functions, remember we said we find inverse functions by switching x's and y's. So like this point, for example, 0, 5. If I switch those x's and y's, we'll get 5, 0. 5, 0 is on this other function, right? Let's get another function, or another point. -4, 1. If I switch the x's and y's, I should get 1, -4. 1, -4, it is on the other function. Okay, so another way to see how you can switch x's and y's and get the inverse function. These two functions are the same function reflected across this diagonal line, this pink line. Let's look at another one that we found. We said 3x cubed plus 3. We said that inverse function was the cubed root of x over 3 minus 1. Whoa, this one looks pretty cool, right? This is the same exact thing that we have before. Okay? Notice how the blue graph, the main function, is just a reflection of the gold graph, the orange graph. They're the same thing. We got that symmetry about this line. And again, any point we pick here, -1, 0, we have 0, 1, -1. 0, 3, we got 3, 0. We just switched the x's and the y's to get from one point graph to the other. That's visually and graphically what inverse functions are. Now, the last thing that we talked about in the last video is we said that the function 2x plus 1 divided by x minus 2, we said that function was its own inverse. And you can really see why right here. Because if we switch x's and y's, so for example, 0.3, 7, switch the x's and y's, we get 7, 3. It's still on the function. In fact, any point you pick, you switch the x's and the y's, you're still going to be on this function. This function is symmetric about this pink line. That's the visual and graphical interpretation of this. All right? So kind of cool. Visually, they're very visually, I don't want to say stimulating, that's kind of a weird word, but very visually satisfying, I think. Okay? So let's go one step further with this. Okay? Let's tie it all together. So, example 5. Talk more about graphical applications of things. Try to find f inverse for f of x is equal to x squared. This is a toolkit function. Well, if we do that, right, we say, okay, y equals x squared. That's our function. Find the inverse. Let's switch the x's and y's. And let's solve for y. So we square root both sides and use the square root property. But when we use the square root property, we get plus or minus. This is not a function, right? If I graphed the function with its inverse relation as an inverse relation, but it's not a function because a given input is going to have multiple outputs. I graph that, let's see what happens. Okay. We just have, okay, y equals x squared. Let's graph its inverse relation, x equals y squared. Oh. Again, we still have that symmetry. But since this orange graph, this inverse relation or function is always just this reflection, it's kind of just this the blue graph always just sideways in a sense. But notice that the orange graph fails the vertical line test. We turn it sideways, it fails a vertical line test. What's a sideways vertical line? A horizontal line. Let's look at another example of this, right? If I tried to find the inverse function of x to the fourth minus x squared, well, the inverse relation of that would be y to the fourth minus y squared. And again, we have this symmetry. But again, the orange graph, this inverse relation is not a function. It fails a vertical line test. But again, the orange is a sideways version of the blue. So what we're going to talk about is a definition called one-to-one. And essentially, it's going to relate to a horizontal line test for the blue graph. So if a function fails the horizontal line test, its inverse will not be a function. Okay? So blue fails the horizontal line test, which means that orange will fail the vertical line test. That has to do with what's called one-to-one. So let's make that more explicit. Okay? Again, this is not a function. So there's no inverse function here. Definition. Let's skip the definition, actually. Horizontal line test. If there exists a horizontal line, again, this is going to be very similar to the vertical line test, that crosses the graph of f, multiple times, f is not one-to-one. A lot of times we abbreviate that one-to-one like that. And f inverse, whoa, that's supposed to be a d. And f inverse is not a function. So again, let's look at one more thing before we actually go on with some examples. Another toolkit function, absolute value of x. Right? Oh, let's turn off pink. This is the absolute value of x function. This fails the horizontal line test for sure, right? Horizontal line is going to cross this graph multiple times. That means that this is not a one-to-one function. It's a function, it passes the vertical line test, but it's not one-to-one, which means it's not going to have an inverse function. And indeed, if we try to plot the inverse function, switch the x's and the y's, look at the orange graph. This is definitely not a function, definitely fails a vertical line test. So again, if something fails the horizontal line test, its inverse fails the vertical line test. And that's known as being one-to-one if it passes both. Okay? So let's do some examples here. Okay? Do the following have inverse functions? Do the following have inverse functions? And notice this is the same exact question as, are these one-to-one? Same question. I could phrase it both ways. Because if it's one-to-one, then it has an inverse function. Okay? And for this, the homework problems in this section, you can use Desmos. Okay? It says use some sort of graphing utility. You can use a graphing calculator. You can use Desmos. It's up to you. Okay? So I'm not even going to write out all the answers. I'm just going to show them all. Okay? So let's just look at some. First one. going to be y equals the square root of x. Why is this not showing up? There it is. So does this have an inverse function? Is this one-to-one? Does it pass the horizontal line test? All of these questions have the same answer. It does pass the horizontal line test. It will have an inverse function. And the inverse function that it actually does have, if I can graph it correctly, is going to be almost x squared, but it has a domain restriction. We're not going to talk too much about domain restrictions, but if anyone's taking trig, that'll come up. So again, notice that these are inverse functions. They are sort of sideways versions of themselves. The other day I woke up to that at about 5 in the morning, and it went on for at least a minute. It was not the happiest morning of my life, assuming that you can hear exactly what I'm hearing. Okay, so yes, the answer is this function does have an inverse. Okay, let's look at the next one. Does this function have an inverse? We already looked at that one. Does this function have an inverse? And again, the answer is no. It fails a horizontal line test. It is not one-to-one. Okay, if we wanted to look at its inverse, we could say, okay, what is 1 over y squared? Notice how this inverse relation fails the vertical line test. All right. Let's look at the next one. X cubed minus x. Again, it fails the horizontal line test. It passes most places, but it fails the horizontal line test around here. Okay. And again, if we tried to see, well, if it did have an inverse, what would it look like? You'd switch the x's and the y's. And whoa, that's not it. Whoa, that looks weird, right? And again, its inverse doesn't pass the vertical line test. That's everything that's going on here. Vertical line tests, horizontal line tests. That's what it means to be one-to-one. Okay, we've got 2 more examples, and then we're going to finish the video. However, first, we need to do something because this is clearly not going to stop anytime soon. Again, see prior mention of getting to experience this wonderful honking at 5 in the morning or whenever it was. All right, great. Much better. All right, next 2 examples. So given the following graph, and I will give it to you. 1, 2, 3, 4, 5. You can't see anything. I'm gonna lose my mind. I can still hear it, even if you can't. I'm gonna lose my mind if that doesn't stop soon. So, given this function, I'm gonna give you a line. I'm gonna ask you a couple things about this line. Okay, find f of 1. So again, this is saying when x is 1, what is the y value of this function? Oh, it turned off. Thank you. Well, when x is 1, the y value is right here. The y value is positive 1 as well. F of 1 is 1. What about f inverse of negative 1? Now, this is a different question, right? F takes in x's, f inverse takes in y's. So this is really asking, right? This is our y. When y is negative 1, what is x? When y is negative 1, that's down here. X is 0 right here. F inverse of negative 1 is 0. Excuse me. Part C. Solve f of x is equal to 3. So again, this is saying what is x when y is 3. So you find y equals 3 on the graph. Look left or right until you find where y is 3. Notice x is 2 at this point. I'm going to say when x is equal to 2. Last part. Find f inverse of 3. And again, this is the same question, right? F inverse takes in y. When is y equal to 3? We already found that. When x is 2. So that's the sort of relationship between these two things. And we can solve them graphically the same way we found them earlier. All right. All right, last example problem. Told you this would probably be the longest video, but here we are. Example 8. I'll make up for it with the next video. The next video is very short. Okay. So given this graph, right here, this is f. Graph f inverse of x. So again, to find f inverse, you switch all the x's and the y's. And if we have a formula, we could solve for y. We don't have a formula, we have a graph. We're going to do it the same way. Switch the x's and y's. So what is a point on this graph? We have 3 that I gave you. This point down here is -3, 0. This point right here is -2, 1. And this point up here is 1, 2. So we're just going to switch all the x's and the y's and see what the function becomes. So if I switch the x's and the y's here, right, this becomes 0, -3. So let's plot that. 0, -3 is right here. -2, 1, switch the x's and the y's, you get 1, -2. Comes like this. Last, switch the x's and the y's, you get 2, 1. Like so. And it should have the same exact shape. So it starts here, doesn't go down, and then goes towards the points. Starts here, doesn't go the other way, and goes towards the points. So every time you graph a function and its inverse on the same plane, remember they should always have that kind of symmetry. Symmetry about this diagonal line, the identity function. That's how you graph inverse functions. Just find some points and flip their x's and the y's, give it the same kind of shape. All right, and that's graphing. All 18 minutes of it. All right, if you have questions, you know where to find me, hopefully, by this point.